already talked about. Absolute value, the idea of absolute value, and solving equations. So we'll be solving absolute value equations, and if you look at the I will board over here, by the end of the lesson, you should be comfortable doing something like this. Okay, this says negative 2 times the absolute value of 3x minus 17 equals negative 5. And I want to begin by sort of leading you into this concept. All these words at the top half of your notes are just the steps for solving. And it's basically telling you, isolate the absolute value, like for here on the board, it would be the 3x thing. And then solve by setting up two different kinds of equations, which I'm going to talk about now. So all this stuff in words, I'm going to just explain while I'm teaching. But if you ever, anytime I do that, like I don't specifically read this out to you or have you read it, I'm not trying to imply it's not important. It's always there for you to read if you're stuck at home and you just need more detail. But the thing that I actually want to talk about is, you don't even have to write it down necessarily. I'd rather you just kind of listen for a minute. And then if you wanted to copy it down, I'll give you a moment. So we talked about absolute value before. We said that it's the distance of a number from 0. And what's one of the more important things that's always true about absolute value answers? Do you remember? Because it's a distance, it's a measurement, it always has to be what? Positive. So if I had an absolute value, this is the most basic form right here of an absolute value equation. Okay, it's an equation because there's an equals, there's a variable, and if I asked you, what two numbers would satisfy that equation, what would you tell me? What two numbers would make that true? 5 and negative 5. I'm hearing 2 and 3. What were you? Were you just giving me something that adds to 5? Okay. That's okay. I'm glad you were thinking and trying. But what I'm really asking you here is, what two numbers, when you plug in for x, would satisfy this? So like if I put 5 in here for x and took the absolute value of it, what would that give me? 5. And if I put negative 5 for x, took the absolute value, what would that give me? Positive 5. Because that's how far they are from 0. Okay? So another way to rewrite the solutions is like this. X can equal 5, or x can equal negative 5. Because if you plugged it in, they would work. If this is something that you're still struggling with, you might want to go back and look at the absolute value section. The hard thing about absolute value is, when we first teach it, it's so simple and easy. Your brain goes on autopilot, and you're not really comprehending the idea. You're just looking at what's in the bars and making it positive. Make it positive, make it positive, make it positive. And you lose that sense of what it really means. It means, how far is it from 0? It's a distance, right? And so when we move into equations, then that's still what you're asking yourself. Whatever is inside here, how far is it from 0? 5 is 5 places away. Negative 5 is also 5 places away. And so this whole thing is the basis for the rest of our lesson today. What we'll be doing is taking an equation like this, making a positive version of it, and a negative version of it. And to sort of set you up for that, I want to talk about what's changed from this form to this form, and this one to this one. So here's the differences. In the original absolute value equation, from here to here, the positive version of it, here's the things that's changed. The bars are gone, right? You see that there's no more bars there? But everything else is the same. Here the bars are gone, but what's changed? The 5 is negative, right? What side of the equation is that 5 on? What side? The right side. So when we go to our more complicated equations and we get to this step, and you're trying to figure out which thing did she say I was making the positive and negative version of, It's the constant on the right. It's just that thing. So no matter what we put in here for the yellow, that never changes. We make two versions, one with the stuff in yellow with no bars and the positive constant. Another equation with the stuff in yellow, no bars, and a negative constant. And that stuff in the yellow doesn't have to be just an x. It could be an expression as well. It could be like this. I might have 3x minus 7 equals 5. So here's my stuff in yellow. Whatever that is, and after I take the absolute value of it to equal 5, it's either I'm going to drop the bars, take the stuff in yellow. I'm going to make a positive version. The stuff in yellow doesn't change, just this number changes. It stays positive here and negative here. So didn't change the stuff in yellow, just change the constant. Have a positive version and a negative. And then you solve those and you get your two solutions for the equation. Okay? And if that is just not clear, or what is it? If it's clear as mud, or do some examples and you should get the hang of it. Okay? Does anybody want this up anymore before I change this? Yes?
So, we're going to start doing the numbers inside of the absolute value.
Mm-hmm.
We're going to pull that up and change the on the other side.
Mm-hmm. Yeah. And we won't do that until we've gotten the absolute value by itself. We've isolated it. Okay. All right, so here's what this looks like in action. We have this equation. Before we can do the two separate equations, we have to isolate the absolute value. So that's the very first step. Isolate absolute value. And this is on your notes as well, but this is just a shorthand way to remember. So here is the absolute value, right here. That yellow stuff. We need to get it all by itself. But what's happening to it right now? Yes. It's being multiplied by 3 on the outside, and then what's on the other side of it? Of that? The negative 14, the minus 14. Well, just like in any regular equation where I'm trying to undo stuff, which thing do I take care of first? Not the multiplication, the negative 14. So when you're solving equations, it's kind of like PEMDAS backwards. And you want to undo addition or subtraction first. And so my subtraction is minus 14. Again, my goal is to get the yellow stuff by itself and then break it up into two equations. So if I add 14 to both sides, that leaves me 3 times the absolute value of n minus 5 equals 12. Okay, again, trying to get the absolute value by itself. Isolate it. Right now it's got a times 3. So I undo any multiplication or division. Undoing times 3. Now, sometimes here people want to distribute. Absolute value does not follow the properties of the distributive property. So don't do that here. Remember, you're trying to isolate it, get it by itself. So it's easier and better, it's more better, to divide by 3 here. So absolute value of n minus 5 is 4. We have successfully done the first step, getting it by itself. Now we drop the bars. And make a positive and negative version. Right, and so I have a true-false question for you. When I make a positive version and a negative version, I'm taking the positive and negative of the stuff on the inside. And if you're not sure what I'm asking, let's look at this back screen for just a second. When I go to make my positive and negative version, I'm making my positive and negative version of the stuff on the inside. It's false. What, in this most basic example, what did I take the positive and negative version of? The right side, the constant, that 5 right there. The stuff on the inside does not change. So in this case, right here at this step, my positive version, the bars drop, the stuff on the inside stays the same, and the 4 stays positive. For the negative version, the bars drop, the inside stays the same, and I make a negative version of the constant. So if you want to add that right here, make a plus and minus version of the constant. You can even make another note to yourself, inside the absolute value doesn't change, if you think you'll forget. And then now we just have these 2 baby equations to solve. Yay, baby equations. It's Friday, we want baby equations. What do you do to both sides there? Solve it by adding 5 to both sides. So for this equation, you get n equals 9. And then adding 5 here and getting n equals 1. And since the problem doesn't specify how to write your answer, you can just box this right here. If you wanted to continue with set notation, that would look like this. Squiggly wigglies, 1, 9. And if you were to take 1 and plug it back into your original equation, or if you were to take 9 and plug it back in, I'm going to just show you real quickly. You don't even have to write this down, but just as an illustration, I'll do it in blue so you can see where my work is right here. I'm going to plug in the 1. So I plug it in. 1 minus 5 minus 14 equals negative 2. Simplify inside the absolute value. That's a negative 4. What is the absolute value of negative 4? Positive 4, so this becomes 3 times 4 minus 14. That's 12 minus 14, which is negative 2. Does that check out? Yes. Okay. Both numbers you put in there would work. Because no matter what, you're going to have either a negative 4 inside here, which becomes 4, or a positive 4 inside there, which becomes 4. Question. We're going to skip the decimal one because I feel like it's the exact same, just with decimals. I don't think that's, you have your calculators. I really don't think that's going to be a problem, so I feel comfortable. But I will have the solution in Google Classroom this evening in case you worked it and you want to know or see where you went wrong. Try this one, please. So doing 2 and negative 2, your math was good. But there's a part in the middle of the problem that should have given you pause. This part right at the step where you've isolated. What's up here that's suspect? The negative. What's true about absolute value? Can't be negative. So no matter what value you plugged in for y, let's say we tested out your 2 and your negative 2. Okay, we'll check it out. Plugging in your 2 for the y, that's absolute value of 4. What is the absolute value of 4? 4. Does 4 equal negative 4? Absolutely not. If you were to have tested out your negative 2, that's absolute value of negative 4. Absolute value of negative 4 is 4. Does that equal negative 4? Absolutely not. So what is the answer for this problem? No solution, right? Squiggly wigglies with nothing inside because absolute value can't be negative. And I had you go through all that work without giving you a heads up. I put can't begin. I'm making up stuff. Because I wanted to illustrate the fact that if you're not intentionally looking for this at that step, you're going to keep on going through your math and there's no other indicators to tell you you're doing something wrong. Your math will work out, it'll feel good and fine and successful. You have to be looking intentionally at this step for if that's negative on the right-hand side. Because it's not going to fail on its own and give you like a heads up that you're wrong. Question? Yeah. Okay. So be careful for that. Does anybody need this up anymore? All right, so this one, kind of crazy looking. What I want you to do is at least get to the isolate the absolute value step, and then I will catch back up with you and get you started on the rest of it if you're unsure about what to do next. So isolate the absolute value, and then we'll regroup. Is I'll have students say, she told us if it's negative on the right-hand side, that's going to be no solution. Well, I got my negative on the right-hand side. I'm just going to stop and say that it doesn't work. But you don't make that decision until you have finished isolating the absolute value. And I haven't finished yet, because what do I still have to take care of? The negative 2. So it's times the negative 2, so I'm going to divide that by both sides. And then on that right-hand side, I no longer have a negative. It's negative divided by negative, which is positive 3. Okay, and this is an awkward problem with all the 3's. This is the step. Okay, so now the absolute value is isolated. I ask myself now, is the constant negative? No, so I can go forward. I make my 2 different equations, a positive version and a minus version. Drop the bars. Everything inside stays the same. Positive constant on the right. And over here, a negative constant on the right. And then now you're just trying to solve for v like you normally would. The weirdness is that there's 3's everywhere. It messes with your brain. There's some negatives and there's a fraction. But if you are following order of operations backwards to try and solve, you know you're going to undo addition or subtraction first. So I have v currently being divided by 3. That's not addition or subtraction. This 3 on the far left is. So it's positive. I undo that by doing the negative to both sides. And now I can undo multiplication or division. It's divide by 3. I'm going to do this one in 2 steps. I'm going to do the other equation. I'll show it to you in 1 step. But maybe right here you're thinking, oh, okay, I'm going to multiply both sides by 3 to cancel that out. Gone, gone. Negative v equals 0. Still not done. I need v all by itself. Right now it's negative, so I'm just going to divide that negative. It's really negative 1. I'm just going to divide it off both sides and get v equals 0. And then you finish the second one, if you haven't already. So here, after you subtract 3 from both sides, I have negative v over 3 equals negative 6. To take care of this in 1 step, as opposed to 2 steps over here, you could just multiply both sides by negative 3. And then it gives you positive v equals positive 18. Okay, I'll take this form or squiggly wiggly form. Okay. Now that's all the notes we're going to do, but I'm not done with you yet. This I will statement, I'm more interested in that statement than you working that one than the decimal problem on your notes. So this is number 17 on the homework I'm about to give you. It's at the bottom right. So when I pass it out to you, just pack it up straight away. Who's always just packing up their homework straight away? Not doing their homework. I'm going to start taking that stuff personally. Not really. If I took that personally, I'd like, I'm going to be able to last you. But it's at the bottom right, so I want us to do that together. I'm going to randomly call someone to show their work at the board, and then and only then will I leave you alone. So it's the I will statement is number 17. It's on the bottom right of your worksheet. I just recorded myself saying all that stuff.